All right, so what's the next step after you get these input IDs, sequence of IDs representing the tokens? The next step is what we call embedding. Embedding is a generic term. What we mean by that is we are kind of representing the information using numerical values. We can represent the information such as text or document or images, but we need to have a way, a predefined way to represent that information. Embedding is a numerical representation, as I just mentioned. The IDs, you can say, oh, we have token IDs. That's a good way of representing. Yes and no. It's a start. We use those token IDs to represent a token. But it's not sufficient to reflect the semantic meaning of the tokens. We'll explain more about that. Just right now, what I'm telling you is that these token IDs, those single numbers, they're not enough to represent the semantic meanings of the tokens. What we need to do is to use a vector space to enable calculation of distance between different embeddings. And really, we use embedding to enable the learning process. Okay, so what do we mean by that? We use this vector space of 3 dimensions to explain why a single number or one-dimensional representation is not enough. If we say we have this example, 3 dimensions, x, y, and z, we have let's say each of these circles is a token that we get from the tokenization process. We have car, fire, net, work, teach, book. Without explaining how we get to this representation, because you can see I put the fire here on this YZ plane, and this car here is in the XZ plane, and work is somewhere here close to this vertex, while teach and book are somewhere here. That's not, going into the details of how we get this. If we look at these 2 words, fire and car. So fire is here, car is here. And they are, relatively speaking, they are pretty far apart. Maybe not far as this net and fire, but they are pretty far apart compared to this teach and book. So the teach is kind of in the center of this upper plane, and then the book is somewhere here, close to this this plane on the right side. So what we want to do is we want to use this 3D dimension so that we can put these tokens in certain places. And if they are close to each other, for example, here we use the angle to represent the distance. If they are close to each other in terms of the angle measure, we say they are closely related. So then my goal of building this 3D this representation is to make sure that if 2 tokens are irrelevant, or you don't see them appear next to each other in the document that often, they should be far apart. Conversely, if these 2 tokens like teach and book appear in the same document or very closely, very often, we want them to be close to each other in this 3D space. So that's my goal. So yeah.
So if the angle between these two is I guess the distance between the concepts, what's let's say if you have things along the same line, like
Yeah.
say book, library,
Yeah.
article,
Yeah.
be close to the same line.
Well, a good question. So you can use angle, you can use the Euclidean distance, you can do different measurement. Well, this is just 3 dimension. In fact, you can expand to hundreds of dimensions. One of these 100 dimensions may be that, let's say, um, teacher use books and student use notepads. Then it may happen that if you travel from teacher book, student notepads, you have to travel along the same dimension. If this is the case, then we're good because we kind of find the relationships in that dimension. If you go this way, this will be kind of
It's like
more logical.
Symmetrical relationship.
Yeah, it could be a symmetrical relationship, or it could be opposite relationship if the other 2 dimensions built in that way. So this is just one example to kind of try to illustrate why we need this multi-dimensional representation of an token ID instead of just a number in the token ID. So the token ID, you remember I showed that you earlier, every token has a number, right? 1055. That number, the single number, represents the token, but that number is not sufficient to represent the relationships, what's the semantic meanings between these tokens.
So like each dimension like represents some like, I don't know, characteristic or something where it's saying you're more or less of this. So is it the more dimensions you have, the more nuance? Yes.
Exactly. So the more dimensions you have, the more angles of semantic or nuances of the relationship will be able to be captured. And of course, there'll be higher cost computation wise, but stay within 1 dimension is not enough. 3 dimensions is not enough. So the models, I think you can easily go to 12,000 dimensions, something like that. So it's a lot more information that will be captured to represent the semantic relationships among these tokens. Does it make sense?
Yeah.
Okay. So using the same 3D as dimensions as example, so each of these tokens that you obtain from the input text, this token IDs will be mapped to its corresponding embedding. Because we have 3 dimensions, so each of these token IDs can be mapped with a vector of length of 3, because we have 3 dimensions. Imagine you have hundreds or thousands of dimensions, so this will be a much longer vector. But that's how a token is really represented in the computer before they are processed by the neural network models. Okay. And in fact, we're going to be using these vectors when we calculate these attentions between them. Okay. Any other questions about this embedding? There's additional reading that you can refer to, following this.